So in the previous lecture I discussed about what concept of null in the pointer. Now today what is our agenda? So today this is our agenda. What means several pointers may point to the same location in the RAM. Also what I will discuss about the size of the pointer variables. So first let me take a few examples. Suppose I am taking int num equals, it contains 10, 15. Okay. Also I am taking char gender, it contains, suppose, also I have what, double, okay. So I have taken three different variables, num, gender and cell. It contains the data. Now I am declaring what pointer variable. So what I am doing means I am going to declare three separate pointer variable correspondingly. So int star p num. Okay. And also we can do like this, means we don't need to write the two steps statements okay, separately. I can do in the single line. So int star p num equals what, ampersand num. In the same way, what, char p gender, p gen shortcut, but here asterisks I missed, equals ampersand gender. Next one, double asterisks p cell equals what, ampersand cell. As you are familiar from this such statements, what means I have the three different pointer variable, p num named p num, p gen, p cell. P num points to the num, p gen points to the gender, and p cell points to the cell variable. Okay, now look at some more what I am doing. First one more points, what is just let me take something here, comma here. What I am taking what, p2, I am taking p3, or you may have the confusion, so I am taking the name what, p num2. Here I am taking p gen 2, and also I am taking p cell 2. Just a minute. Guys, I have taken a three extra pointer variable named p num2, p gen2, p cell2. What is the nature? What is the behavior? Means p num2 is also what, pointing to the integer. P gen2 also point to the what character, means it is also the character pointer, and p cell2, it is also what, double pointer. Okay, now here what I am trying to do, here I am trying to do what, p num2 equals p num p num. Okay, so next p gen 2 equals what, I am trying what, p cell 2, like this. Just focus here. So in this case this is right. but in this case this is wrong. Okay, so why it is right, why it is wrong? Obviously you can assign, means we can assign any pointer address to another pointer address. Okay, but what is the restriction? Restriction is what? Both pointer must be of same type. Same type means we cannot assign one pointer to another of different type, different base type. It is better to use the word base type in case of the pointer. Okay, in case of pointer, instead of what, the data type. Data, we should use the data type word in case of the normal variable, whereas we should use the word base type in case of the pointer variable. Remember this one. So this is the main points. Means we can assign one pointer information, one pointer address to another, but what is the restriction? Base type of both must be the same. Okay, that's why the first one is the right and second one is the wrong. So in this case, now I'm taking one more here, guys. Here taking what? Asterisk p num 3. So what is this? Means I have declared the three pointer variable p num, p-num2, p-num3. In here p-num contains address of the num, but p-num2, it here for your information I can assign here what, null also. It is also valid, guys. I already discussed such concept of the null in the previous lecture. Okay, so p-num2 contains null, p-num3 contains null, but here in this statement I assigned what? I assigned p-num, value of p-num means what is the value in p-num? Address of the num. Okay, so that address is stored into the p-num2 pointer variable. Means again what I am doing here, also I am taking p num3 equals what? p-num2. It is also valid. Also valid. Okay, because base type of the both p-num2 and p-num3 are the same. Okay, but what is the meaning of this one? So means all three pointers named p-num, p-num2 and p-num3 contains the same address. Okay, so this point to same memory location in RAM. Okay, so all three pointers okay, means contains the same address. Okay, which address? Address of the num. Okay, points to the same location, memory location in the RAM. Remember this one. But remember, all these three pointers have different different unique address. Remember this one, don't be confused. Okay, because in the RAM we have p num 2, p num 3. Okay, different. So obviously means what, all these pointers have their address, unique address. Okay, but the contents of these 3 pointers are the same. What is that one? So what address of the num, means address of num is stored, that is, here we can say that is address of num, say 1000 is stored in all these 3. pointers. Okay, you can understand better from the diagram. Let me take the diagram. Suppose we have the this is the different example. We have the age, okay, and we have the 2 pointers IPTR and P1, and these 2 pointers contains the same address 6080 and 6080. But remember, both these 2 pointers IPTR and P1 have different unique address. What is the unique address for IPTR? 5000, and unique address of P1 is what? 5600. So don't be confused. But both these pointers point to the same memory location in the RAM. That is what age. So what is the address of the age? 6080. 6080 is the address of the age. Okay. So this 6080 is stored into these 2 pointer variable. Okay. Now just take the another example. Just I want to get the answer from your side, guys. What do you understand from this figure? I have the 2 variables age and x. Age contains 30 and x contains 1500.50. Okay, and what do you mean by this 4 and what do you mean by this 8? Already I discussed in the very previous lecture. In case of the double, it contains 8 byte memory allocation, continuous memory. In case of age, it allocates 4 bytes allocation. Okay, that's why we have the 4 addresses: 6080, 6081, 6082 and 6083. But in case of the double, I have 8 byte addresses continuous. Okay, but I already discussed means what is the address of the age. I have the 4 byte address, I have the 8 byte address in case of the x. But first byte address is considered as the address of that variable. So 6080 is considered as the address of the age, whereas 5060 is considered as the address of the x variable. Okay. Now these such addresses are stored into 2 different pointer variable. For example, IPTR contains the address of age, that is 6080, and DPTR contains the address of what x, that is 5060. And again remember, IPTR and DPTR, as I discussed in the previous section, means any pointer, whether you have the pointer to int, pointer to char, pointer to float, or pointer to double, each and every pointer occupies the same size memory in the RAM, that is generally 4 bytes. That's why you are watching here. What is the address of IPTR? 5000, 5001, 5002, 5003. Okay, means it as you know, it allocates a 4 continuous byte memory in the RAM. Also DPTR contains what? 4 bytes memory allocation. But what is considered? First byte address is considered the address of that one. So what is the address of IPTR? 5000. What is the address of DPTR? 4020. Okay, so I hope it is clear. Now I am discussing about which one, a size of the pointer variable. Once again, let me discuss one more thing. Dereferencing what? P num p num2 and p num3. What do you mean by dereferencing? Already I discussed in the previous section. Dereferencing pointer means what? Actually you are getting the actual information, actual data which is held at that address. Okay, and again in case of the character only you have the 1 byte information. In case of int you have the 4 byte information at that address, and in case of double you have the what, 8 byte information. So dereferencing means what? Means a system is fetching so many byte information. That's why I have to use what, the base type in the declaration of the pointer variable. Now in this case try to answer this one. Pnum, as you know, pnum, pnum2, pnum3 all contains the same address. That is what? All contains same address. That is what? Address of num. Okay, so here let 1000. So dereferencing this one means what? Dereferencing pnum, dereferencing pnum2 all. What is the meaning of this one? So dereferencing all means we get same information held at that address. That is at 1000. So what is the data? What is the data? So already what it contains, see the on the top, what it contains the 50. So what we will get 50. In the same way you can elaborate for the remaining things. I don't want to waste the time in the remaining portion. Okay, now let me discuss about what size. Size of pointers. So size of pointers already you study, means you have the knowledge, you are familiar about the size of operator. I have what? Size of. I have size of operator. Okay, so what is this one? This is means here parenthesis doesn't mean that it is a function. Pair of parenthesis doesn't mean it is a function, but it is actually an operator. Remember this one, an operator. Okay, so size of is the operator. What is the purpose of this one? It gives you what is the actual size. It gives us what is the actual size. Actual size. Okay, for example, easy. Okay, suppose what I am taking size of, here I am passing what? Int, taking one by one. Okay, what you will get here? So size of char, what you will get? You will get 1 byte. Okay. In the another case, size of int, here, what you will get? You will get either 2 or 4 byte. In this case, you will get size of float. I am taking size of float. we will get also 4 byte. And in the last one, size of double, I will get what? I will get 8 byte. Okay, so this is the means you can test this one by supplying such statements in the printf statements. Okay, for example, sorry, you can verify this. You can verify like this, what? Printf and guys, in case of such statements, we must use the special format specifier, that is what? %u. Okay, it represents what? Unsigned, because the size of anything means I am not getting I am not going to get the what? Negative numbers. Always I will get the what? Positive number. That's why if you are sure, means I have the positive number, so you must supply the format specifier %u. Okay, so here just supply that one, what you want. Okay, so in this way you can verify. Just supply what? Supply such things in the printf statement and you will get the answer. So in this case you will get what? You will get 1 byte. In case of the second one, you will get 2 byte. In case of the 2 or 4 byte, if you have the latest compiler system. In case of oldest compiler, you will get in case of int only 2 byte. In case of the float, size of float, definitely you will get 4 byte. And in case of what? Supplying size of double, you will get the 8 byte information. Okay, fine. Next points. So this is the one way. Also you can, this is the one way. Also I can do like this. What means? Here I supplied in the size of operator, I supplied the what? Data type itself. But now I am supplying not data type, but I am supplying what? Variable name. Here I am mentioning supplying data type. But here I'm supplying what? Supply variable. Okay, so it is also the way. So just a minute. Just a minute. Okay, for example, already I have on the top I have declared so many variables. For example, I have the num, I have the gender, I have the cell, etc. So here I am taking that one. I have the variable what? I think num, size of num equals percentage what? We must use the format specifier %u. Next, here I am supplying what? Okay guys, I will discuss such topic because this is lengthy. I want to elaborate more on this one. I will complete these things in the next lecture. Okay, meeting you in the next lecture. Thank you.